Okay, ladies and gentlemen, welcome. We are talking about wonderful things such as irrational numbers and how to actually deal with them. So remember, irrational numbers do not end, no end, and they do not repeat. But a lot of times you'll see them where it looks like this, a non-perfect square. And then people say, well, what do you do with a non-perfect square? Well, what we're going to do is we're really just going to estimate them. So if I have the square root of 57, and I want to estimate it, I'm going to look at the two perfect squares on either side. So for example, I'm thinking this one might be between 49 and 64. And the square root of 49 is 7, square root of 64 is 8, so it's going to fall somewhere in between there. Now remember, between 7 and 8, there's no whole numbers in between there, but you can have lots of decimals. 7.1, 7.2, 7.3, 7.4, 7.5. You could have 7.212, 7.213, 7.214. You guys get the idea. For the sake of our videos and everything, and our sanity, we are going to estimate or guesstimate, as I like to say, to the nearest tenth. We are going to use an educated guess. So one of the things I want to look at, well, the difference between 49 and 57 is going to be 8 numbers. The difference between 57 and 64 is going to be 7 numbers. So this actually kind of lands us approximately directly in the middle. So 7.5 would not be a bad guess. But because we notice that there's only 7 numbers difference between 57 and 64, we are closer to our 8. So if we were to do this, we could even say 7.6. Okay, so it's kind of hovering around the middle, but closer to the 8, which is why I chose 7.6. Let's try another one. So square root 21. Okay, so if we have the square root of 21, we look at the perfect squares on both sides. So let's see, 16 and 25. What do you guys think? You see how 21, the number 21 falls in between 16 and 25? So this is 4, this is 5, so it's going to be somewhere in between there. So the difference here is going to be 5, and the difference here is going to be 4. I am getting really good at picking the numbers that are in the middle for some reason. And it's closer to 5. So I might say 4, sorry, 4.5, 4.6, something around there. Let's try one that I know for sure is not going to fall in the middle. I apologize about that. So square root of 15. So this is going to fall between square root of 16 and the square root of 9, because those are the two perfect squares surrounding it. So if I listed out the perfect squares, 1, 4, 9, 16, 25, 36. This is where 15 falls. And so when I look at this, this is going to fall somewhere between the numbers 3 and 4. But between 9 and 15, there are 6 numbers. Between 15 and 16, there's only 1. So this is going to end up being, my guesstimate is going to be, that's going to be really, really close to the to 16, the square root of 16. So we'll say it's approximately 3.9, possibly even 3.8. Okay, so these are kind of how we guesstimate or how we estimate our non-perfect squares. And the best part is we can do this using the Pythagorean theorem. So let's look at that. So remember, Pythagorean theorem is a squared plus b squared equals c squared. So I don't have a calculator with me, and I'm just going along going da 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 da, and I know that a equals 3, b equals 5. I don't know what c is, so I'm going to have to use my Pythagorean theorem to find this. So we get 3 squared plus 5 squared equals c squared. So 9 plus 25 equals c squared. And 9 plus 25 is 34. And remember, at this point, because we need to make sure that we know how to balance, we have to take the square root of both sides. So the square root of 34 is equivalent to our c. Now, one of the first questions we ask ourselves, are we looking at a rational or irrational number? Well, this is irrational. It's the square root of 34. Square root of 34 is not a perfect square. However, it's going to come close. So it's going to fall between 36 is going to be the higher one, and the lower one is going to be 25. So it's going to fall between 5 and 6. Now, let's see, there's a difference of 2 here. There is a difference of 9 here. We are much closer to the 36. We are much closer to 6. And I would estimate maybe 5.7, 5.8 possibly. But this is how we can use this with everything we learned from the Pythagorean theorem to estimate our answers, to estimate our irrational numbers, especially with non-perfect squares. And this is where this really happens. This is the implementing of those non-perfect squares. You're not going to go around going, oh, look, there's 17. Let me see if I can estimate the square root of 17. You're not going to do that for fun, unless you kind of really like math like I do. But in general, you don't need to do that. However, we will need to use it if you were using anything using the Pythagorean theorem. So you have a ladder trying to get to a window in a house. You need to know how far it is. You need to know how high it is from the ground to the window, that kind of thing. This is where we will use this. This is where our estimation comes in. Now, along with this, just a really quick side note, because I know people were asking about this, I'm going to show you guys a really cool thing I like for estimating fractions. So let's say we have 3 out of 8. Some of you guys may already know this. I'm going to look at estimating it. So I have 0, and then 1, 2, 3, 4, 6, 7, 8. Okay, and I'm going to put a dot at 3. 1, 2, 3, and this is halfway. So we know 3 out of 8 is less than half. So it's going to be less than 0.4. So we can approximate it maybe, I'm sorry, less than 0.5. Approximate maybe 0.4. What do you think? Maybe 4? Maybe 0.3? So this is where our approximation comes in. If you actually know it, I'm going to grab my handy dandy calculator just to kind of check. Let's find out. So 3 over 8 is really 0.375, which is 0.38 or 0.4. So I think we did pretty good with our estimations. And that's another way you can estimate with these not exactly perfect numbers. And I hope this helps prepare you for your test. Have a good night.